Hello and welcome to New Racing Tutorials. My name is Lloyd James and this will be a tutorial on how to deal with a mesh for a complex object such as a whole car. Once the mesh is open, the first thing you will see is something like this. This large grey box is present because of the way we imported the geometry from Creo. To be able to see inside this box, switch the view to a wireframe. This view allows you to see all of the things that are inside the box, such as the car. As stated in the geometry video, this box is smaller than normally used for the purposes of this demo. One of the first things that should be done is creating name selections. It is very valuable for use in setup and geometry as they enable large areas of the car to be selected simultaneously with the entering of a single name. Some general rules for name selections are that if there is multiple surfaces making up an object, they all should be selected and that object should exist. If there is multiple of those objects, a name selection of the entire set of objects should also exist to make life simpler in the creation of inflation layers. An example of this is the wheels. All wheels are named, however there is also a group for all of the wheels combined. The whole body is also created, as well as the entire car. This allows for quick calculations of things like the coefficient of drag, where you want the force on the whole car without having to enter several names into an equation. While this step is tedious, I feel it is worthwhile as it simplifies a lot of other things down the road. The next step is the mesh. This mesh is quite basic, but it does have some useful features, such as element sizing for the roll hoops, some edge sizing at the top of the roll hoops where the pipes meet, as well as the sizing for the wheel contact points. Things such as edge and face sizing are required on small objects in a model this large. It is also recommended when creating the mesh to set a maximum element size on extremely large domains to prevent the difference between the smallest and largest elements becoming too severe. Inflation layers that you will have seen in MECH 3780 are also used here, the geometry selection being the whole body and the scoping being the name selection that is desired, such as the wheels or the axles. There are two methods of creating inflation layers, the total thickness method or the first layer thickness method. The first layer thickness method better results out of the gate, as it is possible to use some maths to calculate the required first layer thickness. However, this can be difficult to get right in simulation, as the number of layers and the size of the elements needs to be tested multiple times to determine what will make the mesh work correctly. The total thickness gives better mesh stability initially, however it can take longer to perform mesh independent studies to get the Y+ value down to the desired value. Once the mesh has been completed, the number of layers and maximum thickness can be added to the parameters of the simulation. The name should also be changed to that of the object the inflation layers acted on to be able to make sense of the data in the mesh independent study. Once applied to all necessary bodies, the mesh should be updated into the simulation before being closed. With the mesh complete, we can now move on to the setup of the simulation.